Hello, we are going to look at a problem where we might need to use Hess law. However, we shall use a simplified equation to try and come up with standard enthalpy of change of combustion of methane. So the chemical equation for the combustion of methane is given below. We want to calculate the standard enthalpy of combustion of methane. So we want to find the standard enthalpy of combustion of our methane, which is this equation here, using the values of standard enthalpy change of methane, carbon dioxide and water. So one thing to note is that the enthalpy changes they have given are enthalpy changes of formation, and whenever you have enthalpy changes of formation, you can use the following equation to find the enthalpy of the reaction. So in this case, the enthalpy of the reaction we want to find is the enthalpy change of combustion of methane. So we shall say that the enthalpy change of combustion of methane is going to be equal to the summation of the enthalpy change of the products. So we shall have the enthalpy change of our products minus the summation of the enthalpy change of our reactants. So what are the products? Products are carbon dioxide and water. So this means that we are going to find, they have given us the enthalpy of formation of carbon dioxide. So we shall have enthalpy of formation of carbon dioxide. Okay. Let us maintain standard of carbon dioxide plus, we are under products, that of water. However, we have 2 moles of water. So we shall have to consider the 2 enthalpy of formation, standard enthalpy of formation of water, minus, we have the enthalpy of the reactants. We have methane, enthalpy of formation of methane, plus twice the enthalpy of formation of our oxygen. However, we all know that enthalpy changes of elements is always 0, because for us to form oxygen, from oxygen, enthalpy change will be 0. So we are going to ignore our oxygen. So what we have, enthalpy change of carbon dioxide is minus 393.5 plus twice, remember the enthalpy of formation of water is negative 285.8, but we have 2 molecules of water, 2 moles of water, so we shall multiply it by 2 into negative 285.8, this minus the enthalpy change of methane, which is minus negative 74.4. So if you simplify the whole of this, you will come up with negative 890.7 kilojoules per mole. So this will be the enthalpy of this reaction, or the enthalpy change of combustion of methane. So this is our enthalpy change of combustion of methane. So that's how we can calculate enthalpy change if at all they have given us enthalpy of formation of all the substances involved. Thanks for watching. Don't forget to like, share and subscribe so that you are always updated whenever I upload similar content. Stay safe.